Welcome back. Today we're going to be going over some multiple choice and free response questions related to the mean value theorem, but first I just want to briefly discuss what the mean value theorem tells us. The mean value theorem tells us that if a function f or g or whatever it is, if a function is continuous from a to b and differentiable on a to b, then it must be true that there must exist some c value, some value between a and b, such that f of c is equal to f of b minus f of a over b minus a. Now, practicality wise, what is this actually saying? Because this might look like a bunch of gibberish and just be very confusing. Basically, what they're saying is that if on a certain interval f is continuous and differentiable, then there must be some value where the slope, like the average slope from A to B, must be equal to the slope, the instantaneous slope at some point between A and B. So I'm going to say it again, that the average slope from A to B, the average rate of change, the average slope must be equal to the instantaneous slope somewhere on that interval at some value C. That's essentially what mean value theorem is saying without kind of all the formalities here. And I'm going to give you a practical example as well. Let's say you're driving your car and you're driving at 70 miles per hour, and then you slowly accelerate to get to 90 miles per hour. The average, we would say, between those 2 points would be 80 miles per hour. And so there must have been some moment during that time when you were doing that acceleration that you were going exactly 80 miles per hour. There must have been some point when the speedometer passed the 80 miles per hour marker in order for you to get from the 70 up to that 90. Now you might be thinking, oh, but what if we do a huge jerk ahead and that isn't really the case? Well, if that's the case, it wouldn't be differentiable because then there'd be a corner or something like that. And that would not actually be the case in that particular scenario. Okay, but let's go into the actual questions here. I do have a few of them. The first one asks, for which of the following functions does the mean value theorem not apply on the interval from -1 to 1? So remember, for the mean value theorem to apply, it must be continuous and differentiable on all of the points. So let's look at the first one, x cubed. Well, x cubed is actually continuous and differentiable on these points, so I would say it's not that one. 1 over x, I think, is going to be my answer here because notice that one of the points on from -1 to 1, which is 0, would actually be undefined here, right? We have an asymptote at 0, or restriction at 0, and so it is not continuous all the way from -1 up to +1. And so B would be the answer. To go over the other answers, though, this actually would be okay for the square root of x plus 2, right? Because all the way from -1 to +1 here, we would still have valid values here. It would be continuous and differentiable all the way through, so that works. And this also would work for the sine function, right? The trig function as well. If we think about, sine kind of goes like this, that would work for all values of x, so that's completely fine too. Question 2 asks, let f be differentiable on 0 to 5 and continuous from 0 to 5, closed. If f of 0 is equal to 2 and f of 5 is 12, what must be true? All right, so here they're confirming first that the requirements for the mean value theorem are indeed met, since they said that we're differentiable from here to here, we're continuous from here to here, so that's met, that's fantastic. And they're saying that at f of 0 we have 2, and at f of 5 we have 12. So therefore, there must be some value where we get exactly the average, right? There must be some value for which f of 5 minus f of 0 over 5 minus 0 must be like the instantaneous slope at some point of c. So what is f of 5 minus f of 0 over 5 minus 0? Well, let's see. We know f of 0 is 2 and f of 5 is 12. And we know that 5 minus 0 is 5, so that'd be 10 over 5, which is 2. So therefore, at some point, there must exist a point where the rate of change, the instantaneous rate of change, is exactly 2. And so that matches what B is saying here, that at some point, we must cross that 2 marker. We must have 2 as the instantaneous slope at some point. All right, question 3 asks, a car travels 120 miles in 2 hours. According to the mean value theorem, what can be concluded? So the thing is, just ignoring multiple choice here for a second, what could actually be concluded by mean value theorem? Well, the thing is, on average, the car would have traveled 60 miles per hour if it traveled 120 miles in 2 hours. Now, we don't know exactly when the car traveled at different places exactly, right? Like, we don't know, maybe the car traveled really fast at first and then slowed down. But if the car traveled 120 miles in 2 hours, the average speed, the average rate of change there would have been 120, or sorry, would have been 60 miles per hour. So that means the car's speed must have been exactly that there at least one point. Now, maybe it was all the way through, although we don't know that, but we do know that at some point the car's speed must have been exactly 60 miles per hour. And so the answer would be A. In terms of the other ones, it says the car's acceleration was 0 at least once. Well, that's actually not necessarily something that the mean value theorem states per se. C would definitely not be correct. It says the car speed was never exactly 60 miles per hour. Well, we know it actually must have been based on mean value theorem, so that couldn't be the case. And then D says the car stopped at least once. We actually don't know that. It's very possible the car didn't stop, and either way, the mean value theorem doesn't say anything about the car stopping. It just states that the average rate of change must be the instantaneous rate of change at least one time on that continuous and differentiable interval. Okay, so the next one says if f is continuous from a to b and differentiable on a to b, and the derivative of f of x is equal to 0 for all x from a to b, then what does that mean? Well, let's think about that. Consider that the derivative means rate of change. And so if they're saying the rate of change is 0 for all x on a to b, that means that f must be constant, right? If the rate of change is nothing, if the rate just stays the same, it must be constant from a to b. And so my answer would be that A is correct here. All right, let's do a couple of free response questions. The first one says, let f of x equal to x cubed minus 6x squared plus 9x. Part A says to verify that f satisfies the hypotheses of the mean value theorem on 1 to 4. And then B says to find all the numbers that satisfy the conclusion of mean value theorem. Okay, so let's start with part A. Part A says to verify that f satisfies the hypotheses. So the hypotheses are just that the function is continuous from 1 to 4 and also differentiable from 1 to 4. Now, here's the thing. This is a polynomial. And so because it's a polynomial, we know that all polynomials are continuous and differentiable everywhere. And so therefore, those conditions are met. So I'm going to write that down. Something like, since f is a polynomial, that the conditions are met, so that f is continuous on 1 to 4, and also f is differentiable on 1 to 4. And there we go. Okay, part B says to find all the numbers in C that satisfy the conclusion of the mean value theorem. So what would the conclusion be again? The conclusion is that at some point here, we would end up with a value that is the mean, right? And so first I need to find out what that mean actually is. So I need to do find out what f of 4 minus f of 1 over 4 minus 1 is. So f of 4 is going to be 4 cubed minus 6 times 4 squared plus 9 times 4. And that's going to be, let's see, 64 minus 6 times 16, which is 96, plus 36. So overall, that is going to be, looks like 4. Okay, and then f of 1 is going to be 1 minus 6 plus 9, which is also 4 as well. Okay, so then we're going to end up with actually slope of 0 here, because we're going to get 4 minus 4 over 3, which is just going to give us 0 over 3, which is 0. So therefore, I need to set the derivative equal to 0. So let's do that. Let's find the derivative and set the derivative to 0. So the derivative of f of x, just using the power rule, would be 3x squared minus 12x plus 9. And then we can divide everything by 3 and get that 0 must be equal to x squared minus 4x plus 3. And therefore 0 is equal to x minus 3 times x minus 1, which means that x would be equal to 1, and also x would be equal to 3. However, keep in mind that in this case, they need to lie in the open interval, not the closed one, right? They want us to find all numbers from 1 to 4, but not including 1 and 4 that satisfy this. And so we would say this is out of bounds, right? This is out of bounds. It's out of our interval. And so the actual answer then is going to be 3. And so that's my final answer, that c is equal to 3. And that is the only number that satisfies the conclusion of mean value theorem that is also part of the interval that they said that they wanted. All right, let's do one more free response for today. All right, so the temperature T of T in degrees Fahrenheit of a room over a 4-hour period satisfies T of 0 is equal to 72 and T of 4 is 68, and the derivative of T is less than 0.5 on the interval. Explain why there must be a time T naught when T prime T naught must equal to -1. So here they're saying explain why the at some point the rate of change must have been -1. Well, the thing is that we first need to find the average rate of change. So what's the average rate of change over the interval? The average rate of change over the interval, according to mean value theorem, must at some point be equal to T of 4 minus T0 over 4 minus 0, which is 68 minus 72 over 4 minus 0, which is equal to -4 over 4, which is equal to -1. And so by the mean value theorem, there must exist a c value, or in this case, a t naught value, I suppose, for which the instantaneous rate of change is equal to exactly -1, because that's the average rate of change, right? And if we think about it, that makes sense. What's basically happening is at time 0, the temperature starts at 72, then air conditioning's on potentially, and so after 4 hours, it's now down to 68. So on average, it went down by 1 degree Fahrenheit every hour over the 4 hours and ended at 68. And so by the mean value theorem, at some point the instantaneous rate of change must have been -1. Now, maybe it was that average all the way through. Maybe it kind of switched to sometimes being less than the average, sometimes being more, and it all averages out to -1. But either way, it has to at some point be -1, right? That's the one number it has to be someday. Okay. Then let's do part B, which says, is the given information consistent with t prime of t being less than 1, -1 for some t? Explain. So the thing is, it's possible technically, but it's not necessarily the case. So I'm going to explain how come that's not really the case necessarily. The thing is, it could be -1 the entire time. That could just be the rate of change the entire time. However, if it isn't, if that is not the case, then it would be consistent in that scenario, right? Because if there are some times when it's a little bit above the average, then there's also times it's got to be below the average too. But if it's always exactly the average throughout the whole time, then no, it wouldn't be. And so it is possible that maybe this is true, but it's not necessarily always true. We can't conclude that definitely this is true. The only thing we can know for sure about the scenario is that at some point it must cross -1. And so that's the only thing we can know for sure. And so my answer to this would be that no, it isn't consistent because this is not guaranteed by mean value theorem. It's certainly possible. There's scenarios I could make up where this is possible, but there's also the scenario where this doesn't happen, where the rate of change is exactly -1 the whole time, and therefore it never goes below -1 in that particular scenario, only in every other scenario. All right, well, as always, if there's any questions, feel free to leave those down in the comment section, and we'll see you for the next one.